So today we are going to be looking at yet another way to solve quadratics. So at this point, we know we can solve by taking a square root as long as there's no x to the first power. We can solve by graphing as long as we have a graph provided or we have technology to graph for us. We can solve by factoring. Unfortunately, we didn't really touch on this yesterday, but right, if we think about it, we can't factor everything. So as great as that might sound, what are we going to do when we have something like x squared plus 5x plus 1 equals 0? Ooh, well, 1 times 1 is 1. No factors are going to add up to 5. And so now we have a really big dilemma because we can't factor it. So we're not done at just saying, okay, now we'll just solve by factoring. We need to continue on with our list. So we're going to look at yet another way that we can solve quadratics. And that method that we're going to look at today is called completing the square. Okay, so today we're looking at how to solve quadratics by completing the square. Now, the reason I'm doing video notes a little bit different today, right? You're seeing my Screencastify instead of what I normally do for notes, is because I'm going to take you over to another website that has some manipulatives that I want to talk about before we get going too far into this. So just set your pencil down. I kind of just want you to follow along and see. It's going to show us, again, that piece that you guys always think of, oh, someone just magically came up with this idea of completing the square. No, that's not how this works. Okay, so over here on the left side of my screen, you're going to see these blue squares and rectangles, purple, green, whatever. We're only going to be looking at the ones that have the x's. So these up here, we're not worried about y. We're not doing anything with two variables yet. And then we're going to use this one down at the bottom that's just a regular old 1. Okay, so this box right here is representing anytime we have x squared. This box right here is representing any time that we have an x. And this box down here would just be our constants. Okay, so let's say we are given something like x squared plus 8x. If we want to represent x squared plus 8x with these, they're called algebra tiles over here on the side, right? I have 1x squared, so I'd be bringing off an x squared. And then I have 8 x's. So I'd be bringing over 1, 2, 3, 4, 5, right? Just keep dragging 6, 7, 8. Now, the reason that what we're doing today is called completing the square is because we are realistically, literally going to be completing a square. Okay, so we want to arrange these blocks so that we can make a square. Now, the first thing you might say is, I don't think I can do that with the blocks we have. Absolutely, we can't. Okay, so we're going to have to do some math to make it be a square. Now, hopefully we realize that a square has the same length sides. So the length and width are both the same thing. So if I have 8 different x's, would it make sense if I want to start turning them into a square if I put 1, 2, 3, 4 of them on one side, and then 1, 2, 3, 4 of them on the other side. Now, I still don't have a square, right? This isn't enough to make a square. We are going to have to add some more blocks to this to actually make this a square. Okay, so we need to know what we need to fill in right here in this area. What needs to get filled in this area for us to complete the square? Well, to do that, I'm going to have to take these little 1 pieces over here and start filling them in. So I'm just going to start dragging until I have a nice filled up perfect square. Oops, that one didn't quite fall in place, right? Okay, so I'm just going and going. And you might be like, oh my gosh, this is so tedious. You are not going to have to do this every single time. I'm just wanting to show you where this comes from. Okay, so if we count up the number of ones that we used, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We had to add 16 for this right here to make a perfect square. And that's exactly the objective that we're going for today. Okay, so let's look at this now in a little bit of a different relationship of what we need to do to complete the square and now put words to it. So let's say I have x squared plus 10x, and I'm going to complete the square with it. So we need an x squared. Now, if we need 10 x's, how many are we going to put over here? And how many are we going to put over here in order for this to have equal side lengths? Hopefully we will agree with 5, right? We want to put half of them on each side. So we're taking that 10 and we are dividing it by 2 to get 5. And that's telling us how many we want to put on each side. So I'm putting 5, 1, 2, 3, 4, 5 on one side, and then 1. The other side is a little bit more obnoxious because I have to flip them each. 2, 3, 4, 5 on the other side. Okay, now again, I could just start dragging and counting. So I could just start taking each of these ones and filling it into each place. Okay, but if instead of doing this tedious drag and drop, could we figure out how many of these little pieces I'm going to need to put in here? Well, hopefully we go, well, yeah, I just need area, right? I need a 5. This is a measurement of 5, and this is a measurement of 5. So I need a 5 by 5 square. Okay, so to do area with a 5 by 5 square, I'm multiplying those. So 5 times 5 gives us 25, right? I'm taking that 5 and I'm squaring it, which gives me 25. And if I complete this actual process, which I'm almost done with, and we were to count these all up, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, right? We end up with 25 squares. Okay, so we took this 10, we split it in half to get the number that goes over here, and then we're taking that number and multiplying it by itself to get how many we have to add on in the middle. And that is where our whole entire lesson comes from today. So if we want to complete the square, it's all based on what number do I need this C to be? Okay, what number do I have to add? How many of those little pieces do I need to add? Right? And what we did is we said we were taking this middle number. So in this situation, it's 4. And we were going to divide that by 2, which in this case would be 2. Okay, so that now tells me, right, I have a big block and 2 over here. Oh, that should be a little one. And 2 over here. My drawing is awesome, right? So then what would we need to fill in right here, right? Well, we took this number times itself. So 2 squared, or 2 times 2 is 4. So we would need to add a 4. Getting that number is the key to everything else with completing the square working. Okay, now, when we are completing the square today, this is where you are going to want to write. We have a little bit of a switch in rule. We're no longer solving by factoring. We want to figure out what number to add to complete the square, which means if there are any other constants involved, we do not want it on the same side of the equal sign. So we no longer want this equal to 0. Oh, take that back. We want this in the form x squared plus bx equals c. So we want a 1 in front, and we want it equal to a constant. Okay, so let's say we are given x squared plus 6x equals 27. And my guess is that right now you're like, kind of, what the heck, Mrs. McKinney? This feels really overwhelming. Okay, this is very new. This is not something you've ever seen before, you ever done before. Doesn't look a whole lot like anything else. Okay, so we just got to sort of take a deep breath. My students always do very well on this. It just takes a little bit to sort of figure out a new problem. If we want to complete the square on this, our objective is going to be to look over here, right? It's in the right format to look over here and say, what can we do to complete the square? That is going to involve us having to add a number on that side of the equal sign, but we need to find that right number. Okay, so to go through the process, we're going to do exactly what we just represented visually. So our first step is going to be to find b. Okay, so b is always the number in front of the x, so right here. So our b equals 6. The second step that we just did on those last problems was we split it in half. So we're going to divide it by 2. It's terrible writing. Divide by 2. So if I take 6 and I divide it by 2, that's going to give me a 3. Our third step is then going to be, we can either write that out as multiply it by itself, but that's kind of wordy. So I'm just going to say to square it, right? Take it to the power of 2. Because squaring it is the same thing as multiplying by itself. So 3 times 3 is 9. Okay, when we do those 3 steps, we know that this number right here is the number we need to add on to x squared plus 6x to get a perfect square. Now, I can't just add it to one side and still be talking about the same problem. So if I want to add that 9 over here, just like any of our other equation rules, I'm going to have to add it on the other side of the equation. Okay, so our next step is going to say to add that to both sides. And so now we have something that says x squared plus 6x plus 9 equals a 27 plus 9. Okay, but hopefully we realize, okay, 27 plus 9, right? I can add those together. So I have x squared plus 6x plus 9 equals 36. And while that seemed like a not helpful step, it is the world of difference. It makes everything else work out. So now once we have this x squared plus 6x plus 9 equals 36, because we completed the square, we are going to be able to factor this left-hand side. So that's going to be our next step. We want to factor that trinomial. Now you might go, oh my gosh, that's so much work. I now have to do factoring again. Well, we do, but this is going to be a perfect squared trinomial, which means when we go to factor this, we want numbers times 9 that add up to 6. It's going to be 3 times 3. Okay, so it's always going to factor into something that is the format x, a number, squared. And in this case, it's x plus 3. And right now at this point, you're still kind of like, what the heck? Just take a deep breath and bear with me. Once we get through the steps, things feel easier. Okay, so x plus 3 squared, right, is the same thing as x plus 3 times x plus 3. I'm just writing it together in one piece. This still equals 36. Okay, so now let's use some other math things that we've learned over this trimester. Our next step is going to be to get rid of that exponent of 2. And to get rid of an exponent of 2, we use a square root. So our next step is going to be to square root each side. Why? Because now we want to solve for x. So to get x by itself, we have to undo the exponent of 2. Well, we know that an exponent of 2 and a square root cancel each other out. So that just leaves us with x plus 3. It just leaves us with what was there underneath, but without the exponent of 2 in the square root. Now, be careful, right? We know the square root of 36 is 6, but we added the square root. So we need to have plus or minus 6, a positive 6, and a negative 6. Which means this has two options. There are two different equations happening here. Option 1 is that x plus 3 could equal positive 6. I'm using this one. Option 2 is that x plus 3 could equal negative 6. Okay, so we need to figure both of those out. So 6 minus 3 is 3. Negative 6 minus 3 is a negative 9. And so we get two answers, x equals 3 and x equals 9. And if you feel very overwhelmed right now, you're probably not alone. We are not only doing one day of this. So again, just take a deep breath. Okay, now that we've written all that stuff down, let's just look at another problem. So let's say we have w squared minus 8w equals 20. You are going to have to use your notes for a while. But if we think about that visualization with the tiles, right? Now it's at negative 8. We're finding that b. That's our step 1. We're finding b, which is negative 8. And we want to take half of that because we want half of them on each side of the square. So that's negative 4. And we are then going to square it to complete the square. So a negative 4 times a negative 4 is a positive 16. Make sure that turns into a positive. And that's the number we want to add to each side. So this 16 is getting added to each side. So I now have w squared minus 8w plus 16. And 20 plus 16 is 36. Now our next step says we want to factor the left-hand side. And remember, I told you because we completed the square, it always factors into a perfect square binomial. Okay, where we have our variable. Now to make it even easier, it's always this number right here that goes into our binomial. Negative 4 times negative 4 is positive 16, and negative 4 plus negative 4 is negative 8. So we don't even have to do really any work to factor it. We can just pull it from that previous word. Equals 36. And now we are going to square root both sides. Now, just like before, we added the square root. So it is a plus or minus 6. So we have two options. We have w minus 4 equals positive 6, and w minus 4 equals negative 6. Okay, and these are things I can solve. So 6 plus 4 equals 10. And on my other side, negative 6 plus 4 equals negative 2. So I get w equals 10 and w equals negative 2. And my guess is a couple of you at this point are like, Mrs. McKinney, why am I doing this? I could just subtract that 20 and set it equal to 0 and solve by factoring, and I like factoring a lot more. Well, yeah, but again, that first thing I said, factoring doesn't always work. So we're gonna eventually get to problems that we couldn't do by factoring, so we gotta learn this process. Last problem we're gonna look at today. A squared minus 12a plus 27 equals 0. Now remember I said we don't want that 27 over there. We want to complete the square with just these two pieces. So we don't want this equal to 0. So we need to get rid of this 27 to make sure we're even in the right format to complete the square. Now, once we get that 27 moved over, everything else is fine. So we're going to find b, negative 12. Take half of it, -6. Square it. -6 times -6 is 36. And I'm going to add that 36 to each side. Okay, so I have a -27 plus a 36, which will give me a 9. And an a squared minus 12a plus 36. Now I'm going to factor where it always factors into this format, and it is the middle number. So a minus 6 squared equals 9. We will then square root each side. We added the square root to the 9, so that's a plus or minus 3. This has two options. A minus 6 could equal positive 3, or a minus 6 could equal negative 3. Hopefully we agree we can just solve these. So that's an a equals 9 and an a equals 3.